So welcome back to the channel, or if it's your first time here, then welcome. I've made some upgrades to my observatory, and number one is the addition of the Dark Dragon's roof controller system. If you'd like to look back at previous videos of my observatory build and upgrades along the way, please check out the playlist on my channel. There are a few other upgrades and changes that I've made, so let me show you those and how to incorporate them and the roof controller into N.I.N.A. I'll also show you how to integrate the roof and safety controls into an advanced sequence. So let's head out to the observatory, take a look, and then we'll come back to the computer to see the N.I.N.A setup and integration. Okay, here is the DragonLAIR controller, and pretty nice little setup here. Everything is battery powered. We come down here, we've got an AGM 35 amp hour battery, and the DragonLAIR runs on it exclusively. Connected to that is a NOCO battery smart tender, so it keeps the battery charged at all times, so you can leave it on continuously without an issue. Comes up. We have connections that go over to the limit switches, which are up here. These are hard limit switches. So as you can see, as the roof closes, it pushes that switch back. When the roof opens from the other side, the edge of the roof will hit this switch and tell the system that it is open. So these serve as both position indicators as well as start and stop or stop switches. The main drive, it's kind of a neat idea. They use a dump truck tarp motor. My system, as you've seen before, is a chain drive. I've just changed out the motor here with their system. Connects up, it's all 12 volt. The system has the ability, and I'll show you all of this when we get inside to the computer, but the system has the ability to open when the sun goes down and close when the sun comes up, this type of thing. So there is a GPS module here so that it knows your exact location and so forth for that. You also have cable that comes over here to the hand controller. The hand controller can be taken off, and it allows you to manually control either open, close, stop, or then do a full open and a full close. I run an Ethernet network and a Wi-Fi network here in the observatory, so I do have the system connected with a Cat5 cable, which is a little more stable than Wi-Fi. But there is a Wi-Fi cable, a Wi-Fi antenna here as well, so it has the ability to connect either way. The entire thing works as not only a dome controller, but it also works as a safety monitor. So it's an aggregated safety switch. So not only can it work as far as whether or not to open the door and so forth, that you can have multiple sensors on. For me, I also use the Dark Dragon's park sensor. I'll swing around here to the telescope. And if you look right here, this is their park sensor. It is basically has an accelerometer in there so that it knows what the position is of the scope, and you set what your park position is. So when the scope reassumes that specific orientation, it trips to be as parked. And it's just powered by USB power. And all of these devices connect through ASCOM Alpaca. So as you can tell with my scope, I think you can kind of tell here, this 130 millimeter refractor, if it was in the home position, around the door is open here, but if you come around and see the top edge of the roof here in the home position, it would hit. So I'll show you all of the setups inside on the computer later, here for how I manage that within N.I.N.A. Over here, I have a Intel N.U.C computer, and this computer acts a couple of things. It's connected to my Lunatico Cloudwatcher, and it is also my remote server for ASCOM Alpaca for other devices if I need it. It's a server that's on 24/7. The machine that's running on my telescope is only on when I'm in an imaging session. So the relay cable comes from it. I've got it spliced here. That cable comes over and connects to the DragonLAIR. So when the Cloudwatcher, with the settings I have there, are set, when it detects rain or clouds or whatever unsafe condition, it triggers that to the DragonLAIR. The DragonLAIR then sets an unsafe condition, and I can tell N.I.N.A from there that, oh, I need to pause and shut the roof because it could be unsafe here. Just as a side note, over beside here, I do have a Melee Mini. I use the Melee Minis on several of my portable setups. I had an extra one. This one happens to be running my all-sky camera. So that's just why that's there. I remotely control power to most things out here with a CASA power strip. They're connected via Wi-Fi, and I can control those through Home Assistant, which is a home automation software. I also have a WISE Minicam 3 here that gives me a view of the scope and of the sky. Don't need it really with the all-sky camera, but it lets me watch and keep track of the scope when it's running. A few other things that I've added here recently. To power my system, I have a Pyramid DC power supply that powers up. Again, another CASA power strip allows me to turn on my mini computer, which is here mounted to the pier. That's an Astro mini computer, and also powers the telescope. That comes up and powers the scope system up through the saddle, powers and comes over and powers my Pegasus Astro Ultimate Power Box here, which powers all the other devices on the scope. I have also recently added UPSs. So these are very small UPSs, but since a small amount of power is pulled, it'll run the scope for about an hour. I don't have the limits set to that, but I have one here for the scope itself and the pier, and then there's another over here just for the N.U.C, and the purpose of that is to so that the Cloudwatcher stays powered in case of a power outage. And then covered up over here, this is just covering the keyboard and mouse, and then a monitor. And behind that, I have a Raspberry Pi that runs at all times. And this just gives me the ability to remote desktop into the mini computer, which is here on the pier, without having to actually run HDMI cables and keyboard and mouse cables, that type of thing over here to it. I can remote desktop in to it from here in the observatory from this little small desk. And I can also remote desktop into the N.U.C computer if I need it to be able to make any changes there. And then I can also SSH over to the Melee for the SkyCam. So it is the middle of the day here, but I am going to go ahead and open the roof and give you an idea. One of the real nice features is the DragonLAIR has the ability, you tell it to learn about your system, so it knows how long it takes to open and how long it takes to close. And by doing that, then it has the ability to know when it's almost open. It can slow the motor and make an ease soft stop at either end. So I'm going to hit the button to fully open the system. You're going to hear a beep that's going to be a warning to tell you that the roof's about to move, and then it's going to open the roof. As we open, it's going to slow down, and then there we are slowing down. And then it will push over until it touches the limit switch, and it will stop. And then as we close, back in, and we stop, full stop. Okay. Since the DragonLAIR and everything is solely powered by battery, I don't need a UPS here, obviously. And the battery is capable of opening and closing several times. I haven't tested, but I would say probably 5 or 6 times if it was without AC power. I don't know why there's never a scenario that would happen, because if we lost AC power, then my UPS software, which I will show you here, is going to trigger an unsafe condition. That's going to set everything to park, close, and pause, and then it's not going to be safe again until the power comes back on. So just that, for that reason, if something was to happen, it would not leave the system open in case of a power outage. So here we are back inside at the computer, and what I have pulled up here is the web interface for the DragonLAIR roof control system. So this is the main page. Comes up and we've got control, settings, update, and cloud. We'll go through each of these. On the control page, this is what you see. We can open the roof from here. We can close the roof. We can abort if we need to. And then we have some status information. Right now, the roof is fully closed. It is safe to move. And that means that the telescope is parked and it's safe to open. So my safety monitor is good, which means there's enough power to the DragonLAIR and it's not cloudy, it's not raining, and so forth. Down here we see the status of all of our sensors. There are 4 safety sensors, of which I'm not using any of those. You can set up reflectors, you can set up different types of sensors if you wish. Right now I don't feel I need those. I may revisit that in the future. The park sensor, so is showing safe, so the telescope is showing us parked. Safety monitor is disabled, and we'll talk about what safety monitor is here in a second. The voltage, that's the voltage in the battery that is powering the DragonLAIR, is showing in a safe range. The weather sensor is showing safe. This is my Cloudwatcher interface. And then the sun altitude is disabled. Again, as I mentioned earlier, the system has the ability to open at dark and close at daylight, that kind of thing. If you enable that, I do not have that enabled. Under status, we get a little more granular information. Right now, there's 0 current being pulled. The battery is showing 13.88 volts. The roof is closed. It hasn't been manually opened. The roof isn't moving. Auto close is not enabled. Auto open is not enabled. The reason for the last change is the close limit switch was tripped. In other words, the roof closed and tripped the switch to show that it was in closed position. You have the system serial number, the firmware, memory information, free internal memory information, how long the system has been up, the current CPU temperature, and the hardware revision. You also get some charts to show some things. These are the last 200 data points. It updates every second, so this is the last 200 seconds. So this is your power, current, and voltage. Current is 0, it's at the bottom, and voltage, and if you hover, current is 0, 13.88 volts, and it looks like that's been consistent across the time frame here, but that's in the last 200 seconds, 200 data points. Memory, again, free memory, free internal memory, and CPU temperature, and it's fluctuating a little bit, 44, 46, 45. So again, it updates in real time. If you watch closely here, you can see it updating once every second, last 200 seconds. And then network, that's showing the DragonLAIR right now is connected. It's showing its IP address and serial number, its firmware version, the last time it saw it, which is about every second, and its current status is fully closed. The Dark Dragon's park sensor, its serial number, its IP address, the firmware version, when it was last seen, and it is showing us safe to move. And then there's a QR code here you can scan if you want to open this page on your phone. Now this is not an in-depth coverage, by the way, of the DragonLAIR. I just want to show you some of the interfaces. Under settings, you can factory reset, you can put in the device location, or locate the device. If you click on it, the speaker on the device will start chirping. That's if you have more than one device, more than one building, to know that you're talking to the one that you think you are. Download diagnostics, and you can set up authentication so that you have to authenticate to log into it if you wish. Here's where you calibrate your open and close time. If it's fully closed, you can click Calibrate Open. It will open the roof, and it learns how long it takes for that to happen. If it's fully open, you can calibrate close, and it learns how long it takes for that to happen. And then it will adjust accordingly. Here's my location information from the GPS. Here is motor speed. It gives you some parameters here. Minimum speed is 30%, maximum speed is 100. So the minimum speed I have set at 30%, so when it first starts moving, it starts at 30% power, then it ramps up to 100 to open the roof. As it gets almost open, which it learned from the calibration above, it will slow back down to 30% and slowly move it the remaining distance to open the roof. Same thing when it closes, it slow ramps up to moves. As it gets close to being closed, it slows back down and closes, doesn't slam into the wall. Here's where you turn on your safety sensors. Here I have my park mount sensor from Dark Dragons. You can enable, disable the speaker. It talks about the hand controller. An external safety monitor. If you have an Alpaca compatible safety monitor, rain sensor, whatever, you can enable that here and then give it the URL to connect to. Give it a timeout amount. Here's where you set the voltage monitor. I have it enabled, and if the battery voltage gets to 11 volts, it becomes unsafe. And at that point, it will trigger as an unsafe condition and signify N.I.N.A to shut everything down and close the roof. If it gets down to 10.5, it will force close the building before the battery dies. With this in place and your other safety measures in place, that should never be reached. Set where you want the sun altitude to be before automatic open and close. Enable the weather sensor. This is the port that I have the Cloudwatcher connected to. And then enabling auto open, auto close, and so forth. And then follow device. If you have multiple buildings, you can have one device. You can have other devices follow this one. So whatever this one is doing, the other buildings would do the same thing. Think something like Starfront or some of those type of remote observatories. They have multiple buildings. They can have one set up to monitor everything. And when that trip's unsafe, it would then signal all of the buildings to close. And you can save your settings. Update, very simple. This is where you would drag and drop an update if there's a firmware update. And then the cloud connection allows you to configure this so that you can control it when you're off premises through the DarkDragon cloud server. So even though I'm not connected to my network, I could, via my phone through the cloud interface, tell it to open the roof if I wanted to, or close the roof if I wanted to. So there's an overview of the control page for the DarkDragon roof control system. This is the web interface for my UPS system. I'm using an APC UPS. This is their Powerchute software, and this just shows you the load and so forth on the UPS, and gives you some management features here. This really isn't too necessary, but I'll show you that it's online. Right now the UPS is at 12% load. Everything is powered up, everything is on, everything is running, the telescope, all the equipment, and it's telling me that I have 76 minutes of runtime on this battery. You got the battery, the input voltage, and the battery status. And this is where you can go in and to see various different things about the system, like shutdown settings. I have it set up that if the computer is still on, and I would have taken care of all the other things prior to this, but when it gets down to 5 minutes left of battery time on the battery, it will power off the computer or do a shutdown of the computer. But that's basically the only thing in here that really needs to be set. But this is that interface. I'll show you in N.I.N.A how I connect all this together. So here in N.I.N.A on the equipment tab, I'll show you some of the ways that I make things work. I'll start with a switch. So N.I.N.A only allows you to connect to one switch device. I actually have two. I have the DarkDragon's park sensor that I want to monitor, and then I have a Pegasus Astro advanced power box version 3 that I also want to be able to look at and see from within N.I.N.A. The way I do that is I use DarkSkyGeek's ASCOM Switch Hub. It's just a ASCOM driver that you can set up. There'll be links to all this down below. And if I go into the settings here, in DarkSkyGeek's Switch Hub software, you can set up multiple switches. Here's all the switches that I have installed on the system. So you first install the ASCOM driver for the DD park sensor and set that up just like you would a normal switch. The same thing for my Pegasus Astro switch, the Power Box Advanced. And then you just turn on the ones that you want to connect. Say okay. And now when I connect to my switch, and it takes a minute for it to load because it has to go through and it's checking all the devices there and loading them up. And it's a little bit slow to connect, but it works fine. So if you see down here, it says connecting, and I'll speed this part up a little bit. Okay, now we're connected. That took about 35, maybe 40 seconds to connect. So it is a little bit slow on your first connection, but that's okay. So everything shows up here. So marks mount sensor switch. That's the DarkDragon's mount sensor that I have on the scope. And it's right now reading a 1. And that means on or 1 if the mount is parked. If I unpark the mount, if it moves anywhere but that position, this will change to a 0 and show it as unparked. I'll show you that in my sequence here a little later. And then the rest of this is all of the controls that I have for the Pegasus Astro power box. I can turn on each of the USB ports, I can turn on each of the power ports and monitor those, auto do, all of that can be controlled from here. So I have both of those devices, 2 different switch devices. Both of those are now connected within N.I.N.A. Along the same token, under my safety monitor, I have the Safety Monitor Hub installed. Again, links will are below. And if I go into the setup for this, I have both my ASCOM Alpaca safety monitor. This is the Dark Dragon safety monitor from the Dark Dragon roof controller. So it's showing, it aggregates into one itself, into one switch device, or one safety device, the cloud monitor, the Cloudwatcher system. So if it becomes unsafe, then the Dark Dragon's roof controller will register unsafe here. It also is monitoring the voltage of the battery on the Dark Dragon itself. If it becomes unsafe, this will show as unsafe. So if either one of those conditions happen, it becomes unsafe, and that becomes unsafe then within N.I.N.A. I also have the ASCOM generic UPS driver. I'm not going to go into details of that, but that is set up for my APC battery backup, my UPS that's out there. And I have it set up that if it's on battery for 5 minutes, it becomes unsafe. So if the power flashes, I don't care. But if its power is out for 5 minutes, and if we remember, I had 72 minutes of runtime on that battery. So 5 minutes is more than enough. But if the power's been out for 5 minutes, likelihood something is going on. Obviously not a thunderstorm, because if it was doing that, it would be raining or whatever, and it would already been an unsafe condition. But if either of these then shows unsafe, that aggregates back to N.I.N.A as an unsafe condition. And if I connect, it just comes up and just says, check, yep, you're safe. It doesn't specifically tell me which ones are safe or which ones are unsafe. But again, I don't really care. If there's an unsafe condition, I want N.I.N.A to know that, and we want to go into a unsafe segment within our sequence and handle that specific situation. Okay, now I have all the rest of my equipment connected, and here I'll show you under the dome, the DragonLAIR shows up on its IP address, shows the DragonLAIR roof controller. It shows me its condition status right now is closed, and then shows me some other information. I can open the roof or close the roof from here. I can stop it in the middle if I need to stop it from moving for whatever reason, manually, but we have that set up. So I've got my camera, my filter wheel, all this is pretty much normal. My focuser, my rotator, my mount guider. We talked about the switch. I have a DeepSkyGeek flat panel, which is also a dust cover. So I can open and close it. I can set the light and so forth. Here's the train flats and so forth that I've already taught it about. My Cloudwatcher also operates as a observing condition or a weather station. So this is showing the information that it's pulling. I don't really use this within a sequence. It's just nice to have that information. It shows me, you know, temperature, humidity, dew point, wind. It doesn't show me wind speed because I don't have the anemometer on my unit, but that's okay. It shows me the sky quality and the sky temperature, the dome, and then we talked about safety. One nice thing, it doesn't show it on this panel, but if I go over to my imaging panel and come down to weather, it will actually show you the percentage of cloud cover, and it calculates that based on the sky temperature and the ranges that you have set up on the Cloudwatcher. If you want more information about the Cloudwatcher, Logan over at Logan's Astro has a couple of videos on setting it up and how to configure everything. I'll link those videos down below as well. He does a really good job of going through that in detail. So if we go into the sequences, and I'll show you my standard sequence, how I handle things. I have an advanced sequence start with safety. So I use this for every one of my sequences. And basically got some variables. I won't go into that right here, but I wait until safe. So I wait until nautical dusk. minus an hour. I open my roof an hour before I want to start imaging. That gives the inside and the telescope and everything of the observatory have time for the temperature and humidity and so forth to equalize to the outside air. So an hour before nautical dusk, then I start. At that point, I wait till it's safe. So if it's an hour before nautical dusk, but say the Cloudwatcher is showing clouds, then nothing will go farther. It'll sit here and wait until it's safe. Once it's safe, I use pushover to send messages to my phone. Basically, I tell it that we're getting ready to start. I open the roof, and then I wait until nautical dusk minus 10 minutes. So 10 minutes before nautical dusk, I wait until that point of time. Once that happens, I start robocopy, where I'm copying all of my captures up to my NAS in the house, so that I don't have to do that in the morning. They're copying as they come in one at a time. I open the flat panel, I unpark the scope, I move the scope to the home position, I set tracking, and I start cooling the camera. And then I use the night summary plug-in, so I start the night summary. Once that's all happens, and I will switch to Loom. I slew to a position up in the sky where I know it's a lot of good stars. It's almost to the zenith. I run an autofocus, and then I do a solve and sync. So now the mount knows where it's pointing, and I move back to home. But this time, it's now a little bit after nautical dusk, and it's time that I can start imaging. So a standard, we'll just do an LRGB with safety baked in. So if I have a target and I brought that in, these are typical things. You'd have your target there. I set a meridian flip. I set center after drift, delta restore guiding. I wait until nautical dusk. Most likely this has happened because I waited till 10 minutes before nautical dusk before I started cooling the camera, and then I slewed up to near the zenith and then ran an autofocus. So it's probably past that time now, but if it's not, it would wait. Wait till my target's above the horizon. I do have my custom horizon set up. Until I'm getting ready to start, I go to Loom. Typically I wouldn't do this part, but I slew to my target. I set a variable to my rotator. This way, if I want to take flats, I can turn the rotator back to that position wherever the rotator is after I have slew centered and rotated on my target, and I can go back to that specific position and catch flats if I want to. Start guiding and run an autofocus. Normally I would disable this. This is just kind of a catch-all, but I've already done an autofocus at the very beginning. There's no reason to do it again here. And then I autofocus after a 10% increase in HFR. I loop until nautical dawn or while it's still above the horizon. And at this point, I start taking my images. Now, one thing up here in the top triggers, you see when becomes unsafe. So if sometime during the night while it's running this imaging sequence, and it has to be in this same area where your meridian flip, center after dark, and restore guiding, where those kind of triggers are, the global triggers for this particular target, when it becomes unsafe, what do I want to do? I send an alert saying, oops, it's unsafe. I stop guiding, I stop tracking, I park the scope. Remember, my scope has to be parked before I can close the roof. I wait until the mount set sensor switch says it is parked. Okay, so yes, park scope. That sends a command, ASCOM command to your scope controller software. In my instance, it's Commander because I'm running an Ioptron Sim70 scope mount. It should stay there at park scope until the Commander software reports back that it parked. Just to be on the safe side, I now wait until the mount sensor says it's parked. It should be, and this should just skip right through, but it's just another level of safety to make sure that I'm parked and I'm out of the way. I close the dome. I send a message saying, hey, everything's gone into safe mode. We're in lockdown. We're waiting. And it will sit there until it becomes safe. Once we go back to safe, then I send an alert back saying, oh, everything's cool. Now we can go. The clouds have passed. Whatever has happened is passed. We can continue on. I open the dome. I unpark the scope, or open the roof, unpark the scope, set my tracking, slew and center back to my target. I don't need to rotate again because I didn't change the rotation. I start guiding, and at that point, it will fall right back into wherever it was down here in the imaging sequence. So if it was on the third green image or whatever, it would come back and pick right back up on that image and continue on and continue cycling through unless clouds or whatever come through again. So this is a typical sequence. I'll show you my typical end sequence. There's nothing specific to safety in this, but my advanced sequence end. I'll drop down here so you can see what that looks like. I tell it to park the scope. I wait until it's parked. Once again, belt and suspenders here. I say the scope is parked. I close the roof. I send a message saying the roof is closed. I close the flat panel cover. I'll tell RoboCopy it can stop now. I end the night summary system so that it will create its report. I start warming the camera. Once the camera is warmed, I send a message saying I'm done with this target, done sequence for the day. So if there's any questions, leave a comment down below and I will go through and show you how that all works, or I'll try to answer anything. This is pretty straightforward. So far it has worked very well, and we'll see what happens in the future. So I'd like to thank you for watching. Hopefully this was informative. Again, if I can help with anything, if anything here wasn't clear, if you have any questions, be sure to leave a comment below. I'll get back to you and let you know and answer it if I can. Huge shout out to Jeff and Rick over at Dark Dragons Astronomy. Those gentlemen are absolutely fantastic. They have a Discord server that you can join. They're very, very quick in getting back to any questions or anything that comes up through this entire process. They were just above and beyond. Can't say enough. Their website is linked down below. The Safety Hub software, I'll have that linked down below. The DeepSkyGeek's Switch Hub software, I'll have linked down below. And also, obviously, the Dark Dragon Astronomy website is linked. So thanks again. Hope you learned something. And please, all the YouTube-y things, like, subscribe, comment. Until next time.